Good day everyone. Our topic for today is about trigonometric and inverse trigonometric function.
The discussants are the following: Maria Victoria Cinco, Juliet Monleon, April Los Falcon, Jonalyn Villamir, Inami Solara, Nasalyn Sabinorio, John Rico de Lima, Rosalie Villamir, and Joanna Morada. The PPT editor is Maria Victoria Cinco and the video editor is Inami Solara.
Exercise 5.1. Roman number 1. Find the first derivative of the given function y is equal sin 5x. Solution. In using chain rule, the chain rule states that in the case of sine function, the derivative of sin u is equals cos u times derivative of u with respect to x. So the inside function is 5x, or u is equals 5x. Now, let's solve for the derivative of u with respect to x. U is equals 5x. U plus delta u is equals 5 times x plus delta x. U plus delta u is equals 5x plus 5 delta x. Transfer u in the right side, we have delta u is equals 5x plus 5 delta x minus 5x. Subtract 5x, we have delta u is equals 5 delta x. Divide both sides by delta x, we have delta u over delta x is equals 5. So, the derivative of u with respect to x is 5. Therefore, in using the rule given above, the derivative of sin 5x is equals cos 5x times derivative of u with respect to x. Substitute the value of derivative of u with respect to x. We have cos 5x times 5 is equals 5 cos 5x. So, the derivative of y is equal sin 5x is 5 cos 5x.
Find the second derivative of the given function. The given function is read as the function of v is equals to sine of t plus tangent to t. First, we will find the derivative of v, which is equals to sine of t plus tangent to t. In this given function, in order for us to get the derivative of v, we will apply the chain rule to solve the given function. We know that the chain rule states that the derivative of y with respect to x is equals to the derivative of y with respect to u, times or multiplied by the derivative of u with respect to x. So, the solution of the given function are follows. The derivative of v with respect to t is equals to the derivative of sine of t with respect to t plus the derivative of a tangent u with respect to u multiplied by the derivative of 2t with respect to t. Remember that u is equals to 2t. So, the derivative of sine t with respect to t is equals to cosine t, while the derivative of tangent u with respect to u is equals to secant squared u. The derivative of 2t with respect to t is 2. So, the derivative of v with respect to t is equals to cosine of t plus secant squared u times 2. We will multiply the secant squared u to the constant 2, which will now result to 2 secant squared u. After that, we will now substitute the value of u, which is 2t. So, the first derivative of v with respect to t is equals to cosine t or cosine of t plus 2 secant squared 2t or times 2t. To find the second derivative, consider the following. The derivative or the first derivative of v is equals to cosine t plus 2 secant squared 2t. We will use again the chain rule which I have already mentioned earlier. So the second derivative of v with respect to t is equals to the derivative of cosine t with respect to t plus 2 multiply the derivative of secant squared u with respect to u. Let us first find the derivative of secant squared u with respect to u. Using the power rule, we can come up with the result 2 secant of u multiplied the derivative of secant of u with respect to u. So, the second derivative of v with respect to t is equals to negative sine t since it is the derivative of cosine of t plus 2, open parenthesis secant, u, close parenthesis. Secant u times tangent u. So, 2 times 2 is 4. 2 times secant u is 2 secant u. So, let us simplify this and we will get 8 secant u times secant u times tangent u. The second derivative of v with respect to t is equals to negative sine t plus 8 secant squared u and tangent u. To get the final answer, we will substitute the value of u, which is 2t, to the result that we come up. So, the second derivative of v with respect to t is equals to negative sine t plus 8 secant squared 2t times tangent 2t, or the second derivative of v with respect to t is equals to 8 secant squared 2t times tangent 2t minus sine of t.
Find y prime of the given implicit function. So the given is xy squared equals tan x plus 1 squared plus 1. So we will now convert it into y squared equals tan x plus 1 squared over x plus 1 over x. Now, differentiate on both sides with respect to x. So, 2y dy over dx equals x 6 squared x squared plus 2x plus 1 times 2x plus 2 minus tan x plus 1 squared times 1 over x squared minus 1 over x squared. So, we will now get the y prime. So, y prime equals dy over dx equals x 6 squared times x plus 1 squared times 2x plus 2 minus tan x plus 1 squared minus 1 over 2x y times x squared. So, y squared equals tan times x plus 1 squared plus 1 over x. It equals to y square root of tan x plus 1 squared plus 1 over x. So, the y prime of the given implicit function is y prime equals x 6 squared times x plus 1 squared times 2x plus 2 minus tan x plus 1 squared minus 1 over 2 square root of tan x plus 1 squared plus 1 over x times x squared.
Exercise 5.2. Find the slope, tangent, and normal lines to the given curves at the point indicated. 1. Y is equals to sine 2x. Since the derivatives sine u and derivatives cos u, then dy is equals to cos 2x times 2 dx. Cos 2x times 2. So the derivatives of sine 2x is 2 cos 2x. In the given application, we have to find the slope, tangent, and normal lines. So first, let's find the slope. The slope at point pi over 2 and 0. Derivative 2 cos 2x. 2 cos 2 times pi over 2 cancel 2, so 2 cos times pi. So the slope at point pi over 2 and 0 is derivative of negative 2. For tangent line, y minus 0 is equals to negative 2 times x minus pi over 2. Y minus 0 is equals to 2x plus pi. So y is equals to 2x plus pi plus 0. So the answer is y is equals to negative 2 plus pi. In normal line, y minus 0 is equals to 1 over 2 times x negative pi over 2. So the answer is y is equals to 1 over 2 x minus pi over 4.
Find the critical points, determine the maxima and minima, and find for the inflection points of the given curves. So y is equals to sine x plus cosine x. The first derivative of f of x with respect to x is cosine x minus sine x. Set the first derivative equal to 0 and solve. Cosine x minus sine x is equal to 0. Divide each term in the equation by cosine x. So, cosine x over cosine x plus negative sine x over cosine x equals 0 over cosine x. 1 plus negative sine x over cosine x equals 0 over cosine x. Separate functions. 1 plus negative 1 over 1 multiplied by sine x over cosine x equals 0 over cosine x. Convert sine x over cosine x to tangent x. So, 1 plus negative 1 over 1 multiplied by tangent x equals 0 over cosine x. 1 minus tangent x is equals to 0 over cosine x. Separate functions. 1 minus tangent x is equal to 0 over 1 multiplied by 1 over cosine x. Convert 1 over cosine x to secant x. So 1 minus tangent x is equal to 0 times secant x. 1 minus tangent x is equal to 0. Subtract 1 from both sides of the equation. 1 minus tangent x equals 0 minus 1. Negative tangent x equals negative 1. Divide each term by negative 1. Negative tangent x over negative 1 equals negative 1 over negative 1. So tangent x equals 1. Take the inverse tangent of both sides of the equation to extract x from inside the tangent. X is equal to arctan 1. The exact value of arctan 1 is pi over 4. So x is equals to pi over 4. The tangent function is positive in the first and third quadrants. To find the second solution, add the reference angle from pi to find the solution in the fourth quadrant. So x is equal to pi plus pi over 4. To write pi as a fraction with a common denominator, multiply by 4 over 4. So x is equal to pi times 4 over 4 plus pi over 4. Pi times 4 over 4 plus pi over 4. So x is equal to pi times 4 plus pi over 4. 4 pi plus pi over 4. X is equal to 5 pi over 4. The period of tangent x function is pi, so values will repeat every pi regions in both directions. X equals pi over 4 plus pi n, 5 pi over 4 plus pi n for any integer n. Substitute the two values of x from the given equation. Sin x plus cosine x equals sin pi over 4 plus cosine pi over 4 equals the square root of 2 over 2 plus the square root of 2 over 2 equals the square root of 2 plus the square root of 2 over 2 equals to the square root of 2 over 2 cancel equals the square root of 2. Sin x plus cosine x sin 5 pi over 4 plus cosine 5 pi over 4 equals negative the square root of 2 over 2 minus the square root of 2 over 2 equals negative 2 the square root of 2 over 2 cancel equals negative the square root of 2. Therefore, the critical points are pi over 4 plus 2 pi n the square root of 2 and 5 pi over 4 plus 2 pi n negative the square root of 2. The second derivative of the function is negative sine x minus cosine x. Evaluate the second derivative at x equals pi over 4. So negative sine pi over 4 minus cosine pi over 4 equals negative the square root of 2 over 2 minus the square root of 2 over 2 equals negative the square root of 2 minus the square root of 2 over 2 equals negative 2 the square root of 2 over 2 cancel. So negative the square root of 2. X equal pi over 4 is a local maximum because the value of the second derivative test is negative. Find the y value when x equals pi over 4. So, sine pi over 4 plus cosine pi over 4 equals the square root of 2 over 2 plus the square root of 2 over 2 equals the square root of 2 plus the square root of 2 over 2 equals 2 the square root of 2 over 2 equals the square root of 2. So, the local maxima is pi over 4 and the square root of 2. Evaluate the second derivative at x is equal to 5 pi over 4. So, negative sine 5 pi over 4 minus cosine 5 pi over 4 equals the square root of 2 over 2 plus the square root of 2 over 2. The square root of 2 plus the square root of 2 over 2 equals 2 the square root of 2 over 2 equals the square root of 2. So, x is equal to 5 pi over 4 is a local minimum because the value of the second derivative test is positive. Find the y value when x is 5 pi over 4. Sine 5 pi over 4 plus cosine 5 pi over 4 equals negative the square root of 2 over 2 minus the square root of 2 over 2 equals negative the square root of 2 minus the square root of 2 over 2 equals negative 2 the square root of 2 over 2 equals negative the square root of 2. Therefore, the local minima is 5 pi over 4 and negative the square root of 2. In finding the inflection points, this is the same as the way of finding the critical points as I've explained lately. But here, the given is the second derivative which we set it equal to 0 and then solve. The inflection point in this case are 3 pi over 4, 0 and 3 pi over 4, 0.
A wall is 3 meters away from a building. The shortest ladder that can reach the building with one end resting on the ground outside the wall is 10 meters. So the question is, how high is the wall? So using Pythagorean theorem, we can get the height of the wall or the altitude of the triangle. So the formula for the Pythagorean theorem is a squared plus b squared equals c squared. So since we are looking for the height, we can use the formula which is a is equal to square root of c squared minus b squared. So when we substitute the value which is 10 and 3, a is equal to square root of 10 squared minus 3 squared. So a is equal to 100 minus 9. 100 minus 9 is equal to square root of 91. So a is equal to 9.539, and then when we round off, it is equal to 9.54. So therefore, the height of the wall is equal to 9.54 meters.
Okay, next we have here the exercise 5.3, part 1. Find the slope, the tangent, and normal lines to the given curves at the point. So kung i-analyze natin itong problem, wala siyang naka-indicate na point. So we will assume na nasa point 0 and 0 siya. Next, we have here the sample problem. Y is equal to arcsine for x. Kung titingnan natin itong given na problem, naka-form siya into inverse trigonometric function. So, paano natin ito sasagutin? Firstly, aalamin na muna natin kung ano yung different derivative of inverse trigonometric function formulas. And firstly, we have here the derivative of arcsine u is equal to derivative of u with respect to x all over the square root of 1 minus u squared. Second, derivative of arc cosine u is equal to negative derivative of u with respect to x all over the square root of 1 minus u squared. The third one is that derivative of arctangent u is equal to derivative of u with respect to x all over 1 plus u squared. Next, derivative of arc cosecant u is equal to negative derivative of u with respect to x all over u and the square root of u squared minus 1. The fifth one is derivative of arcsecant u is equal to derivative of u with respect to x all over u and the square root of u squared minus 1. And the last one is derivative of arccotangent u is equal to negative derivative of u with respect to x all over 1 plus u squared. And yung nalaman natin itong different derivative of inverse trigonometric function formulas, saka natin sasagutan itong given na problem which is itong y is equals to arc sine 4x. Firstly, i-identify muna natin kung ano yung u and yung derivative of u. Ang yun natin is itong 4x. And the derivative of u is equals to 4x. 1 minus 1 is equals to 4x raised to 0. And any number raised to 0 is equals to 1. So we will multiply 4 and 1. And 4 times 1 is equals to 4. So ang derivative of u natin is equals to 4. And kung titingnan natin dito, ang ginamit na problem is yung arcsine. So we will use the formula for arcsine. And ang formula natin for arcsine is ito, which is the derivative of arcsine u is equals to derivative of u with respect to x over the square root of 1 minus u squared. And ang derivative of u natin is itong 4. So this will be 4 over the square root of 1 minus u squared. And ang u squared natin, ang u natin is itong 4x. So we will substitute for x squared. And this will result to 4 over the square root of 1 minus 4x squared is equals to 16x squared. So ang answer natin is 4 over the square root of 1 minus 16x squared. And since nakuha na natin ang derivative nitong y is equals to arc sine 4x which is equal to 4 all over the square root of 1 minus 16x squared, ang sunod naman natin kukuha na ng value is yung value ng tatlo which is yung slope, tangent, and the normal lines. First is the slope. Okay, paano nga ba natin hahanapin yung value ng slope? Ang pagkuha ng value ng slope is isa-substitute lang natin kung ano yung given na value ng x. And ang given na value ng x is equals to 0. So substitute is equals to 4 all over the square root of 1 minus 16. And the value of x is equal to 0. So isa-substitute 0 squared. Kasi squared dito. Which would be equal to 4 all over the square root of 1 minus 16. And 0 squared is equal to 0. Would be equal to 4 all over the square root of 1 minus and 16 times 0 would be equal to 0. Next is equal to 4 all over the square root of 1 minus 0 is equals to 1. Which is 4 all over the square root of 1 is equals to 4. So ang value natin for slope is 4. And next is the tangent line. Sa tangent line, we have the formula y minus y sub 1 is equals to m sub t times x minus x sub 1. Wala tayong value for y, so magiging y na lang siya. And ang value naman natin for y sub 1 is equals to 0. And m sub t naman, or the slope, is equals to 4 times x. Wala tayong value for x, so x na lang siya. And ang value naman natin for x sub 1 is equals to 0. Then, substitute. Y minus y sub 1. Value ng y sub 1 is equals to 0. Is equals to m sub t, or the slope is equals to 4 times x minus x sub 1 is equals to 0. Then, multiply. Y minus 0 is equals to 4 times x is equals to 4x. And 4 times 0 is equals to 0. Then, ang gagawin naman natin dito is, ililipat natin itong 0 dito. So, magiging y is equals to 4x plus 0 and plus 0. So, this will be y is equals to 4x. Or, 4x minus y is equals to 0. So, this is the value for the tangent line, which is y is equals to 4x, or 4x minus y is equals to 0. And the last one, we have the normal lines. Sa normal lines, we have the formula m sub n is equals to negative 1 all over m sub t, which is the slope, which would be equal to negative 1 over the value for m sub t is equals to 4. So this will be negative 1/4. So ang value natin for m sub n is equals to negative 1/4. Then, we will use the formula y minus y sub 1 is equals to m sub n times x minus x sub 1. Wala tayong value for y, so magiging y na lang siya. And ang value naman natin for y sub 1 is equals to 0. Ang value naman natin for m sub n is equals to negative 1/4. And wala naman tayong value for x, so x na lang siya. And lastly, ang value naman natin for x sub 1 is equals to 0. Then, substitute. Y minus 0 is equals to m sub n, which is equals to negative 1/4 times x minus x sub 1 is equals to 0. Then, ang gagawin natin dito is ililipat natin itong 4 dito, which would be equal to 4y minus 0 is equals to negative 1 x minus 0. Then, multiply, which would be equal to 4 times y is equals to 4y. And 4 times 0 equals to 0. Is equals to negative 1 times x is equals to negative x. And negative 1 times 0 is equals to 0. And ang sunod natin gagawin is, ililipat natin itong 0 dito, which would be equal to 4y is equals to negative x plus 0 and plus 0. And ang equal nito is 4y is equals to negative x. Or 4y is equals to negative x. Para makuha natin lang yung value ng y, i-divide natin siya both by 4. Which would then be equal to y is equals to negative x over 4. So yan ang value natin for the normal lines, which is 4y is equals to negative x, or kung kukunin lang natin yung value ng y, this would be equal to y is equals to negative x over 4. So yan ang normal lines.
Part 2. Find the first derivative in the given implicit function. Number 1. X squared times y is equals to open parenthesis x plus y close parenthesis squared cos raised to negative 1 times 2x. So, here's the solution. In order to solve this problem, we will move the expression of x squared times y equals to open parenthesis x plus y close parenthesis squared cos raised to negative 1 times 2x to the left side in order to change its sign. So, ito ay magiging x squared times y minus open parenthesis x plus y times cos open parenthesis 2x close parenthesis raised to negative 1 equals to 0. Then, we will set the function related to the equation and we will put the f open parenthesis x and y close parenthesis, which may be called a function of two variables. So, f open parenthesis x and y close parenthesis equals to x squared times y minus open parenthesis x plus y close parenthesis cos open parenthesis 2x close parenthesis raised to negative 1. So, to find the first derivative, we will use the formula dy over dx equals to negative fx over fy. So, we will first find the first partial derivative with respect to x. So, f open parenthesis x and y close parenthesis equals to x squared times y minus open parenthesis x plus y close parenthesis squared times cos open parenthesis 2x raised to negative 1. So, fx equals 2xy
minus 2x plus 2y over cos, open parenthesis 2x, close parenthesis minus 2 open parenthesis x squared plus 2xy plus y squared, close parenthesis, sine, open parenthesis 2x close parenthesis over cos, open parenthesis 2x squared close parenthesis. And then the next one is we will find the first partial derivative with respect to y. So f open parenthesis x and y close parenthesis equals to x squared times y minus open parenthesis x plus y close parenthesis squared times cos open parenthesis 2x close parenthesis raised to negative 1. So fy is equals to x squared minus 2x plus 2y over cos open parenthesis 2x close parenthesis. And then we will find the required derivative by substituting the first derivative with respect to x, which is equals to 2x minus 2x plus 2y over cos open parenthesis 2x close parenthesis minus 2 open parenthesis x squared plus 2xy plus y squared over cos open parenthesis 2x close parenthesis and the first derivative with respect to y, which is equals to x squared minus 2x plus 2y over cos open parenthesis 2x close parenthesis into dy over dx equals to negative fx over fy. So dy over dx equals to negative 2x minus 2x plus 2y over cos open parenthesis 2x close parenthesis minus 2 times open parenthesis x squared plus 2xy plus y squared close parenthesis sine open parenthesis 2x close parenthesis divided by x squared minus 2x plus 2y over cos open parenthesis 2x close parenthesis. So, when there is a negative sign in front of an expression in parentheses, we will change the sign of each term of the expression and remove the parentheses. So, dy over dx equals to negative 2xy times cos open parentheses 2x close parentheses squared minus cos open parentheses 2x close parentheses times open parentheses 2x plus 2y close parentheses minus 2 open parentheses x squared plus 2xy plus y close parentheses sine open parentheses 2x close parentheses squared divided by cos open parentheses 2x close parentheses times x squared minus 2x minus 2y over cos open parentheses 2x close parentheses. So we will now simplify the expression. So the first derivative of x squared times y equals to open parentheses x plus y close parentheses squared cos raised to negative 1 times 2x is equals to negative 2xy times cos open parentheses 2x close parentheses squared minus cos open parentheses 2x close parentheses times 2x open parentheses 2x plus 2y close parentheses minus 2 open parentheses x squared plus 2xy plus y squared close parentheses sine open parenthesis 2x close parenthesis over cos open parenthesis 2x cos open parenthesis 2x close parenthesis times open parenthesis x squared close parenthesis minus 2x minus 2y close parenthesis.
Find the second derivatives of the given functions. Y is equals to x, sin raised to negative 1x squared. In finding the derivatives, we must substitute first the given functions and identify. Using the product rule, which is the derivative of y is equals to u times the derivative of b plus b times the derivative of u. And substituting, which is u is equals to x, the derivative of u is equals to 1, b is equals to sin raised to negative 1x squared, and the derivative of b is equals to 1 over the square root of 1 minus x squared. This is equals to x times 1 over the square root of 1 minus x squared plus sin raised to negative 1 times x squared times 1. It is equals to the derivative of 1 is equals to x over the square root of 1 minus x squared plus sin raised to negative 1 x squared. The second derivatives is equals to 1 over negative x squared plus 1 raised to 3 over 2 plus 2x is equals to the square root of 1 minus x squared.
Part 4. Solve the problem. So the given problem is a ladder 3 meters long leans against the wall of a building. The top slides down at a rate of 0.25 meter per second. How fast is the angle between the ladder and the ground decreasing when the angle is 30 degrees? So for the solution, shown in your screen is on how I derive for the representation of the given of the following problem. So the hypotenuse is the ladder, and the shorter leg the shorter leg is the y variable, and the longer leg is the x variable. So angle 30 degree is in between the 3 meter and the x variable. So the derivative of y with respect to the derivative of t is equals to 0.25 meter per second. So we will going to find out or find the result of the derivative of x with respect to the derivative of t. For us to come up with the final answer, we will use the Pythagorean theorem to serve as the implicit function of the given problem, since the given representation is a right triangle. So when we have a right triangle, we will use the Pythagorean theorem, which is a squared plus b squared is equals to c squared. So in the given problem, we have the x squared plus y squared is equals to 3 squared. Then, since it is an implicit function, we will solve for the derivative of an implicit function. So, in solving an implicit function, we will find the derivative of each term, then multiply it by 1/2. So, the derivative of x squared is equals to 2x by using the power rule, and the derivative of y squared is equals to 2y by using again the power rule. And the derivative of a constant is always equals to 0. So, we have now the results, which is 2x times the derivative of x with respect to the derivative of t plus 2y times the derivative of y with respect to the derivative of t is equals to 0 times 1/2. So the whole equation is, we will multiply it by 1/2. So we will cancel the 2 since we are going to multiply the given equation to 1/2. So cancel out the 2 into x and the 2 into y. So we have the results of x times the derivative of x with respect to the derivative of t is equals to negative y times the derivative of y with respect to the derivative of t. So we will separate the x and y in this process. Then next, we will come up now to the final answer for the equation that we are going to find. So the final equation that we will use in finding the derivative of x with respect to the derivative of t is equals to negative y over x times the derivative of y with respect to the derivative of t. So before we proceed to the next step, we will first find the value of x and y by using the basic functions of trigonometry. So for y, we know that y is in sine, since opposite, it is based on the given angle, it is equals to the opposite over hypotenuse. So for y is equals to 3 sine 30. So we use the sine, the basic functions of trigonometry, sine. And when we solve for the y value, 3 sine 30 is equals to 1.5 meter. So next, for the value of x, we know that based on the representation above, x is a cosine, since we all know that cosine is equals to adjacent over hypotenuse. So the 30 degree is a cosine. So x is equals to 3 cosine 30. Since x, which is the adjacent to 30 degree, and the 3 meter, which is the hypotenuse of 30 degree. So 3 cosine 30 is equals to 2.6, or 3 square root of 3 over 2. So x value is equals to 2.6 meter. So we will use the 2.6. Then after that, we will substitute the value of x and y to the equation that we come up earlier. So the derivative of x with respect to the derivative of t is equals to negative y over x times the derivative of y with respect to the derivative of t. So we will now substitute the value of y and x. So the value of y is equals to 1.5 meter, while the value of x is 2.6 meter. So the derivative of x with respect to the derivative of t is equals to negative 1.5 meter over 2.6 meter multiplied by the given derivative of y with respect to the derivative of t, which is equals to 0.25 meter per second. So by simplifying the given equation, we have now the results of negative 0.144 meter per second, meaning the derivative of x with respect to the derivative of t is equals to negative 0.144 meter per second. The final answer states that by solving the equation and all, it is noted that the negative sign, which is we come up as our final answer, indicates that the angle between the ladder and the ground is decreasing. So the speed of the angle between the ladder and the ground decreasing when the angle is 30 degree is 0.144 meter per second. So that's the group answer of the section BSE 2B. Thank you and God bless.